Hi, this is Kay. I'm going to be doing number 21 from the practice exam. So number 21 says, the scatter plot shows the time spent texting X and the time spent exercising Y by each of 25 students last week. Write an approximate equation for the line of best fit of data if it doesn't have to be the exact line of best fit. Okay, so what we're going to do is we're going to approximate a line of best fit. Now how you do that is you look, well, the data is going downwards, so we know our slope is going to be negative. And we pick in the middle, between the middle of the points, and we just draw a line. It's approximately in the middle. It's not a very good line. Let's see, that's approximately in the middle. Okay, so on Alex, you would actually pick 2 points that you thought were going to be on this line that goes down. It doesn't have to be some of those points plotted. It can be any 2 points that you think would fit on your line that you drew. And then you would draw a line between them in Alex. But for me, since I'm doing it on just this piece of paper, I am just going to draw a line of best fit and estimate the points. So I have a point on my line of best fit about at 1, 9. So I'm going to call that 1, 9. And I have another point on my line of best fit about at 9.5, 1.5. So it's my first line of best fit. So I'm going to pick another point, 9.5, comma 1.5. Awesome. Okay, so I've estimated 2 points that are on my line of best fit. So the only thing that some people have been getting wrong is that if you draw your line of best fit here, you don't want to pick this point because it's not on your line of best fit, right? Okay, so pick 2 points that are on your line of best fit. Then you have 2 points, so you can estimate the slope. The slope, m, is the change in y over the change in x. That's delta, change in x. Okay, so we take our first point's y value minus our second point's y value over our first point's x value minus our second point's x value. So 9 minus 1.5 is 7.5. 1 minus 9.5 is negative 8.5. And now, if you want to make this nicer, so it's not decimal fractions, what you can do is you can plug this into your calculator, say 7.5 over negative 8.5, and then there's a function called, if you go into math and then click fraction, it'll turn it into a fraction for you, and I did that before, and so I got negative 15 over 17. So negative 15 over 17 is the fractional form of 7.5 over negative 8.5. So that's our slope. So now we can write an equation. Y equals mx plus b. So our m is negative 15 over 17. So y equals negative 15 over 17, x plus b. Now we are going to use one of these points. Either one works. I'm just going to use 1 and 9 because those are nicer. And we're going to find b. So we're going to plug 9 in for y and 1 in for x. So we have 9 equals negative 15 seventeenths times 1 plus b. So negative 15 seventeenths times 1 is negative 15 seventeenths. So we're going to add that over to 9. And you can make 9 a fraction over 17 by multiplying 17 times 9 over 17. And then add these 2 fractions together, and what you get is 1/68 over 17 is equal to b. So then what we do is we have our slope and we have our y-intercept, so we can write the equation. Y equals negative 15 over 17 plus 1/68 over 17. So this is our equation. This is part A. And now we want to read what part B is asking. Part B is asking, using your equation from part A, predict the time spent exercising for a student who spends 6 hours texting. So I just deleted that part of this so that we had more room to work. So part B is really asking, if x equals 6 hours, what does y equal? So then we plug x equals 6 into our equation that we created in A to find y. So when x equals 6, we do negative 15 over 17 times 6 plus 1/68 over 17. And that is equal to y. So let's see what that's equal to. I calculated it before. You can do it on a calculator or in your head if you're awesome. So y equals 78 over 17. And that would be our answer to part B. Thank you.